In this video, we will go over how to use the power property of logarithms to simplify. So what is the power property? It's highlighted here in yellow. It states that the log base b of m raised to the n power is equal to n times the log base b of m. So we can use this property to go back and forth between these two problems. So let's look at an example. So here we have 3 times the log base 9 of 4. This matches the right side of our property. We want to convert it so that it matches the left side. So we can take our coefficient, this guy out here, is going to come up here and become an exponent on that 4. So, so we would have log base 9 of 4 raised to the 3rd power. Let's look at another example. So here in example 2, we have 2 times the log base 8 of 7. So it matches the right side. We want it to match the left side. So we can take that coefficient, that 2, and move him up top to become an exponent. So we would then have the log base 8 of 7 raised to the 2nd power. In example 3, we have a log base 4 of 3 all being divided by 3. At first glance, it doesn't look like it matches our power property, but in reality it does. Dividing by 3 is the same thing as multiplying by 1/3. So if we rewrite that as a 1/3 times the log base 4 of 3, it now matches that property, so we can apply and use it. So we would take this coefficient and move him up top to be an exponent. So this would then become the log base 4 of 3 raised to the 1/3 power. The 1/3 power means the cube root, so you could also have wrote this as the log base 4 of the cube root of 3. Either way would be an acceptable answer. In example 4, we have 5 times log base 12 of 11. It matches our power property, so we can take this coefficient and move him up top to be an exponent. So we would get a log base 12 of 11 raised to the 5th power. And that would be our final answer. Let's look at another example. Here we have log base 7 of 10 all divided by 2. Well, dividing by 2 is the same thing as multiplying by 1/2. So let's rewrite that so that it matches our power property. Now we have a 1/2 times the log base 7 of 10. Now we can take that coefficient that's out front and move him up top to be an exponent. So we have log base 7 of 10 raised to the 1/2. 1/2 means square root, so you could also write this as log base 7 of the square root of 10. And that would be your final answer. In example 6, we have 6 times the log base 5 of x. It matches our power property, so we can take this coefficient and move him up top to be an exponent. So here we would then have a log base 5 of x raised to the 6th power. Let's look at another example. Here we have m times log base 2 of 25. It matches our power property, so we can take that coefficient and move him up top to be an exponent. So we have log base 2 of 25 raised to the m power. Let's look at another example. Here we have a log base 4 of 13 all being divided by u. Well, we can rewrite that as a 1 over u times the log base 4 of 13. Now it matches our power property, so we can take that coefficient and move him up top as an exponent. So we would arrive at log base 4 of 13 raised to the 1 over u. 1 over u would be the uth root. So you could also write that as log base 4 of the uth root of 13. Let's look at example 9. Here we have 9 times the log base 18 of p. It matches our power property already, so we can take that coefficient and move him up top to be an exponent. That leaves us with a log base 18 of p raised to the 9th power. Let's look at one last example. Here we have a log base 3 of x, all divided by 4. Well, that's the same thing as 1 over 4 times the log base 3 of x. Now it matches our power property. We can take this coefficient and move him up top to be an exponent. So that would leave us with a log base 3 of x raised to the 1/4. The 1/4 power is the same thing as the 4th root. So we could write that as log base 3 of the 4th root of x, and either of those would be an acceptable final answer.